Thank you. Great to see everybody in 3 dimensions. Well, almost everybody. I've got Ben Bussey around here. He's better in 2 dimensions. So following on from Rosemary's talk and some of the things that we heard Greg say, we go forward to the moon together. Everybody goes forward together, not one group against another. I've been dealing with moon or Mars about 25, 30 years now. It's moon and Mars. It's not moon to Mars, because moon to Mars makes it, the moon very ephemeral. We'll do just the minimum amount of the moon and then we'll bog off to Mars. No, moon and Mars. Exploration and science go hand in hand. Much of the same data we get for science can be used for exploration. We're doing it right now using orbital data to evaluate lunar resources. So there we go. So I want to point to our current United States space policy. It's all about sustainability and sustainable and sustained. If you look at NASA's moon to Mars objectives, those words do not feature anywhere. And they need to be, because having sustainable human exploration of any planet requires it be built in from the very beginning. We go forward together, not in opposition, but together. We work out our differences. I thoroughly agree with what Rosemary said. Environmental impact assessment is essential to do mining on this planet. And why do we know that? Because exploration went forward without science when we were developing the resources on this planet, and we screwed up. And if we don't learn from history, we're going to be destined to repeat it. But nothing should be prohibitive. We need to look at both sides and work out compromise. Compromise is important as we go forward. So looking at our space policy, permanent human presence is touted in goal number 6. If we look at the principle, number 4, we're going to pursue the extraction and utilization of space resources. It's going to be critical for sustainable exploration. Now, we don't go and do that without understanding those resources, and that's the crux of this particular presentation. Let's look at NASA's messaging. In NASA's plan for sustained lunar exploration and development, we need a coordinated resource evaluation campaign as the next critical step in order to have sustained long-term presence on the lunar surface. We've got to develop that over the coming decades and generations. And next gen folks, no pressure, it's on you. Maybe a little bit of pressure, a lot of pressure. But we need to have our presence grow. We need to be able to survive and thrive off planet. And that's why I had that quote on the initial slide from Kraft Eric, paraphrased, if God intended humans to be a spacefaring species, he'd have given them a moon. Oh, we got a moon, and it's got resources. How do we use those responsibly in order to have sustainable human exploration? Jake also pointed out this particular document. We need to know the reserve potential of lunar resources to fully develop exploration technologies and enable a sustainable space economy with supporting utilities and commodities. We need to understand what's there. So we need a resource evaluation campaign. Understanding what's there will feed into exactly what Rosemary was talking about. Are they fragile deposits at the poles? We don't know. Maybe. Are they renewable? Probably not, but we don't know. Are they renewable on what time scale? That's the other thing. And Artemis Accords. I love the Artemis Accords, because we got to learn from history. We look at Apollo. Apollo was done in a spirit of competition. And less than 4 years after we won, we stopped. And we celebrate 50 years in December since the last humans walked on the moon. Let's not have another 50 years after Artemis 3, Jake. Just saying. So we look at resources and reserves, it's a critical distinction because resources have been used in those documents when they actually mean reserves, and we have no idea if there are reserves on the moon. So I like to think we have three broad categories of potential lunar resources. We've got the regulars, all-encompassing, volatile-bearing pyroclastic deposits and polar volatiles. You find in the regolith all your metals, you can find those in the pyroclastic deposits, so on and so forth. But a mineral reserve is the economically mineable part of a measured or indicated mineral resource. But we can't understand the reserve potential because we have no ground truth data. We've got orbital data and the markets are not developed. And I point you to those references for a little more in-depth discussion of that. So what data do we need? This is the list that we've come up with. Composition, form, distribution, geotechnical properties in areas that we've never been to, near surface regolith stratigraphy, accessibility. And you see all the way over to the right, what is the required fidelity? Depends on the stakeholder. What about science? What about exploration? What about commercial entities that want to develop business plans in conjunction with lunar scientists and the engineers that do our exploration systems? We're going to the moon together. We're going to compromise. If we don't go to the moon together, we're going to shoot ourselves in the foot and we're going to go on a journey to nowhere again. So hey, everybody's got to get along. And I think we can. And I'm very excited about the resources because they're going to bring us together to have these discussions and move forward together. So orbital data, they've been used already. You could see those references there in that table to the right from Ollie Brown's excellent paper, came out this year in Icarus, with the top 21 potentially best PSRs to explore in terms of water ice, what we know now. Orbital data can inform accessibility, and we've got ShadowCam launching on KPLO in a matter of weeks. It's going to give us glimpses into PSRs at the scale needed to start making traversability maps, or not. You could put your Artemis base camp next to Shackleton Crater, but if you can't get to the deposits, what's the point? If we're going to use ISRU, we need something that's usable. This is going to give us the data. But the orbital data don't give the clarity about the form of the deposits or the geotechnical properties needed. We need to understand those to understand extractability. High resolution data could help inform where to put surface assets. Neutron data, getting down to about 5 kilometers per pixel, is a big improvement on what we currently have. Shows us the subsurface potential of hydrogen, remember. Instrumented penetrometers, deploy those from orbit to give us point data on a little less grand scale than we saw from L-Cross. But it wouldn't destroy a large area with that little penetrometer going in and then give us data back on those particular deposits. So the needed spatial resolution is going to require surface assets, mobile surface assets. That'll give us the understanding for geotechnical properties and the extractability. It will also inform science. It will understand the longevity of that. When we get compositional data back, we'll understand what the contaminants are. Or are they? One person's contaminant is another person's resource. This could be very informative, but we need meter or decameter scale data in order to build up what the deposit actually looks like and what the grade of deposit actually is. So initially, maybe investigate the top 10 in the Brown et al. Paper. Needs to be international in nature. And again, you look at the data that we're going to come back, we're going to involve multiple stakeholders in that. So we could be an immediate orbital phase, then less capable rovers, but a lot of them. And then we go the more capable rovers to those areas that give us our highest probability for success. The data is going to inform multiple stakeholders, but we've got to go there to get those data. So work is needed on data requirements, implementing and coordinating the campaign, data sharing and transparency, defining what an international lunar resource evaluation campaign actually looks like. And we started that with SLSW on the 11th of July. Come to the league meeting. You'll find out more about the results from that if you didn't attend. But we need to start now. We've been talking about ISRU ever since I've been working on lunar stuff. And it's still not in the critical path because we don't know enough about lunar resources. So we need to obtain consensus on the data requirements to evaluate these resources. And we'll start with the polar volatiles. They seem to be the low-hanging fruit, or are they? We don't know. We need instruments and mission scenarios that would attain such data. And we invite international and commercial participation to coordinate this campaign. It has to be a campaign because the real estate is immense. And I don't want to end up 50 years from Artemis 3 having to show, well, I don't think I'll be around, but somebody may show this. And I think that that's something that's going to be critical. That we need to start thinking, what is the next step that's going to enable so much more? And I truly believe a coordinated international lunar resource evaluation campaign is that step. And I was asked to put this in, and of course I didn't include my email address. But cneal@nd.edu or Google Clive Neal Notre Dame, and it comes right up. So if you want to subscribe to the Lunar L, send me an email. Sure. Okay.
Thank you.